didn't see that. Oh, we saw
Happy birthday, Mike!
11 years old today.
It's Mike's birthday. He didn't want us to mention it, and I was like, you know that if any of my family's watching, that they're gonna say something, and there's not gonna be anything you can do about it. And that was the first thing you guys did, so you didn't disappoint.
Nuh-uh.
Well, thank you.
Cool.
Yeah.
All right.
Sure. Totally.
Well, here we are.
Uh-huh.
Yeah. I don't know if Brandon remembers how to host things.
What? Yeah, it's just you counting down and I say hello. That's basically how this works.
Oh, look at that, Katie. Katie, take that mic.
Yeah.
And Jack is with us as well.
Excellent.
Cool.
Excellent.
Cool.
Thank you, everybody.
Birthday
And we
podcast.
shall.
We're going to talk about how Mike was built.
How Mike? Well, that's a story. I'm
Yeah.
sure.
Yeah, no.
Not the real way. In a more grand, universal way.
I imagine it's like when they built the Statue of Liberty with scaffolding all up down when it was being stacked in New York. I imagine it's like that, but with helicopters instead of cranes. Really big helicopters putting Mike together.
Yeah,
with scaffolding all around.
Am I that big?
Larger than life.
No, in my head now, you're like 6 times the size of the Statue of Liberty. Just like a monument to.
This is like Gulliver's Travels,
Look,
right?
look,
So it's all the little.
Look, Jack doesn't even. He's like, who's the stranger in the middle?
Hey,
Because
yo.
you've been gone. So no one remembers
I was
you
just gone
anymore.
that one time. There was another time I was
there
gone.
was 2 times.
Yeah.
It was like 2
Oh,
times.
Is that why
yeah.
it feels like?
It feels weird that you
Yeah.
don't. Yeah.
It's like why have I?
Yeah, you
why
haven't
have-
been here in a while.
Oh no.
Yeah.
Let's make up for that.
Okay.
Let's
well,
have a good time.
Let's get this party started then. You
Yeah.
ready?
Give me a countdown,
All right,
Liz.
We're going
Let's
live.
do it now.
We're already live, but we're starting the actual podcast in 5, 4, 3.
Every time.
He has forgotten, yes. He does not remember how to do it.
I was giving us a moment so we can edit in a brief pause.
Yeah, he's giving me an edit beat.
Welcome back, everyone, to another fantastic episode of Cosmos with Cosmos. I'm Brandon.
I'm Mike.
And I'm Liz.
And today we're talking about, well, what are the building blocks of the universe?
Yeah.
That's kind of a big question.
How
Legos.
Legos?
how to build a Cosmo in the cosmos, if you
Yes.
will.
Oh, which is basically what we did today. We built ourselves. Mike built all of us a Cosmo in our current Cosmos.
So Mike's the creator.
Which, by the way, this is the first time that we've had
Yes.
Cosmo.
So for
on
our
the-
drinks, kicking it off, we have Cosmos.
Let's get a
Finally,
little
for the
tink for the
first
podcast. Tink.
Ding, ding.
There you go. These are horrible tinking glasses.
All right, so before we talk about, how to build a universe and all that fun stuff, we should probably talk about our drinks. Now, we said we're having Cosmo, but what are the building blocks of a Cosmo drink?
Good question.
Mike?
Fancy alcohol man?
Citrus vodka, in this particular case, citrus vodka, cranberry juice, lime juice, and triple sec, which we finished all the triple sec. We killed it.
Excellent.
So, yeah, that's a pretty simple building blocks.
Yeah.
So you get your cranberry taste, you get your orange
Mm-hmm.
with the triple sec, get your lime,
Mm-hmm.
and then of course the citrus flavors of the vodka.
And it's very refreshing.
And you shake it all up.
You do shake it. A lot of shaking going on.
So there are our first drinks for this podcast. And we also have a couple of rules, don't we?
We do.
What are our rules, Liz?
Our rules are, if any dogs bark, take a drink. If we do any Star Wars or, now that Brandon's back, Lord of the Rings references, take a drink.
Hey.
That's it.
That's
all
it?
the rules.
Okay, that's all the rules.
Yeah.
I feel like there was like one more.
Yeah,
We were going to add another one, but I can't remember what it was.
We're a fairly lawless household here, so just got a couple rules.
Yeah.
Just got to stick by them.
Yeah.
Just don't break them. And of course, feel free to give us a follow on the Twitter at Drinking Cosmos, the Instagram Cosmos with Cosmos. I think that's all the social media we have.
It's all the socials.
That's all we need.
It's all on the YouTube.
Oh, the
Follow us on
YouTubes,
all
of course, the
things.
YouTube.
Like us on all the things.
Like us, yes. Send us postcards if you would like. Skittles, always fantastic.
No, because we're not giving our address out on the
One,
internet.
no, here for everyone.
Select few
here
people
is
have our
here
address.
is the address. It's 1234 West Fake Street Drive.
There we go.
Yes.
Okay. Jack is drinking sun-brewed iced tea. Ooh, my dad would brew iced tea in the sun. He'd have a thing, and he'd put it outside for a while, and then it would be in the fridge. And then it had one of the, had one of the little buttons you press for the little spout on it, on the pitcher. And so when it was in the fridge, then I would go underneath it, and I would... I would drink it.
Of course you would.
That way. But anyway, sun-brewed iced tea with Latvian chocolates for nibbling.
Wow.
Ooh, perk of an exchange teacher. Oh, nice. Okay. So those are like real Latvian chocolates. I guess I don't think about what things are like. Food, candy is like in other countries.
I know in other countries they have actual chocolate as opposed to the Hershey's chocolate we have here. They just have better building blocks over there for chocolate.
Oh, okay.
Yeah.
Well, before you can build any chocolate, you gotta create the universe.
Make the universe.
Yeah.
Yeah, so when we talk about building blocks of the universe, there's a lot of different types of building blocks. We have itty-bitty, infinitesimally small building blocks to create matter, for example. We have bigger things, bigger building blocks to make planets, moons, solar systems, and even bigger building blocks to make galaxies and giant superstructures. So I guess we should start with the smallest building blocks. The smallest turtle, that's all the way down. The foundation.
The
Very foundation.
Foundational blocks.
Yeah.
So
Particles,
yeah. That's exactly the segue I was going to make. Particles! The smallest itty-bitty things that we know of. Maybe those particles are made up of other things. But let's first talk about the particles, and then we can talk about possibly what other things may be.
Well, we have particles like that have weird names, right? Like you got like gluons and muons, but then you have quarks and leptons. But then there's strange things and charming things and things and down things and
Finnegan's Wake. Yes.
Yes.
Let's start with the Greeks.
Oh, okay.
Oh,
Let's start with the Greeks. So the Greeks posed the question, and it was probably around before the Greeks, but the Greeks posed the question: if you have a block of something and you cut it in half, and keep cutting that in half, you finally get to the most basic brick building block of that object, and they called it an atom. And so. They had probably a Greek name for it, but
it was like a atomus by who was it?
Democritus.
Atomus.
It just stood for indivisible, so you can no longer divide it at this base point.
Yep, and so it was the smallest that you could get, and that pretty much, stayed the way that we thought for a long time. Then we found out that the atom actually can be, it has things that make it up.
So it's not the smallest.
It's not the smallest.
We have to go deeper.
The Greeks were wrong about a lot of stuff.
They were kind of right about things too.
They did a
good job.
A for effort.
Well, better than the Romans.
But did they delve too deep?
Too greedily. That's a drink.
That's a drink. Yeah.
Okay, so in the late 1800s, in the first part of the 19th century, we found out that the atom is actually made up of smaller constituents, and we eventually found out that it's made of electrons and protons and eventually neutrons. One of my most favorite countries in the world, New Zealand, they have a scientist on their money, Ernest Rutherford, who actually figured out that the atom is actually mostly empty, and in the center of it you have the nucleus, where you have the protons and the neutrons, and then you have the electrons.
How did he figure that out?
He shot a bunch of alpha particles at gold, and alpha particles are, I believe it was alpha particles.
Yeah, it was alpha particles.
Okay, it was alpha particles. He shot at a leaf of gold, gold plate, and basically what he did was he measured. Actually, his assistants measured where those alpha particles bounced. So they would hit the nucleus and they'd bounce off, and you can figure out where they hit.
I love this idea. He's not doing this in the giant CERN lab we think of today. He's doing this in like 1910, and he's shooting charged alpha particles, and it's just so much fun.
Yeah. Yeah, I know, right? And so before Ernest Rutherford, J.J. Thomson, who Rutherford actually studied under, Thomson said that the atom was kind of this plum pudding model where you have neutrons, you have protons and electrons just kind of all together, and Rutherford showed that was not correct. Yeah. But so we find out that we have protons and neutrons, eventually neutrons anyway, and Rutherford's on one of the dollar bills for New Zealand.
Nice.
And that's because they fucking, take pride in scientists and people that advance the world.
Speaking of science on money, Canada has Canada Arm, which I love Canada Arm so much. Yeah, ISS. Really, anytime NASA needs an arm, they go, "Hey, Canada." Canada's like, "You gonna need an arm?" Yeah, we do. And it's a beautiful relationship.
And what does our money have? A pyramid, an eye, and some religious crap.
Yeah, some religious
dead
crap.
president.
Well, that's slowly changing now.
That's true. And not without a fight.
No, Harriet Tubman on the 20. Eventually.
Okay.
Yeah, but it's all right. So,
back on track.
Anyway.
So we eventually found out that through a lot of experimentation and stuff in the 1960s that protons and neutrons actually aren't that most basic indivisible building block. They actually are made up
smaller?
It goes smaller. They're made up of things called quarks.
Quarks, like in Star Trek?
Yeah, spelt that way.
Every time I hear the word quarks, I immediately think of Quark from Star Trek.
I think of, is that James Joyce? Yeah, that was him.
So, all right, so protons, and there are 6 types of quarks, and you have up and down.
Oh, these are the quarks.
Yeah,
okay.
So these are the quarks, taken from Finnegan's Wake.
Can I say them so I look like I'm smart and know things about physics?
You know things.
Okay, there are 6 types of quarks, everyone.
6.
It is up, down, charm, strange, left,
top
and bottom.
Yes.
Damn it.
Excellent.
Damn it.
Left and right.
Left and right.
Well,
You know what was
we already
great?
had up and down, so I was
it-
like, top and bottom seems redundant.
It sounds like we're naming these types up, down. It feels like we're putting a cheat code from Nintendo.
It does. Up, down, charm, strange, top, bottom.
Ha!
Triangle.
Now our main character's got 16 times smaller.
So in a proton, you actually. Oh, okay. I'm thinking about this now. All right. So in a proton, you have 2 up quarks and 1 down quark, and in a neutron, it's actually flipped. You have 2. You have 1 up and 2 down.
So those neutrons are real downers.
Hey, you know what? That's a good way to remember it. Those neutrons, they're so neutral. Just pick a side.
Yeah.
You're just a downer.
Yeah. So there you go. And those quarks are the right now we think that they are the most
Smallest.
indivisible. They're the smallest. They have so they're fundamental. Now, of course, I mean we can always go into the debate of what strings are and that type of thing, but that's for a different podcast.
Yeah, we already talked about string theory in our another episode.
So one of the best ways I remember, particles is with chemistry. You have the periodic table. It lays out everything about the chemistry and the elements. But now with these particles, you have the standard model, and that is what the 12 of them kind of laid out in the table. Each one belongs to their own family and gives their own types of properties. So it's kind of convenient looking at that and thinking, okay, everything kind of fits nicely into this model.
Yeah. So you have things called fermions and bosons, basically. But
before, I think we should maybe explain a little bit more of like why can we explain why these quarks are named the way they are?
Oh.
Because it's a little confusing. So, yeah, Katie's like,
It doesn't
directions,
get
charmed,
any
and
easier.
strange. What?
No, they're taken
Flavors.
from...
Don't forget flavors.
Yeah, they're taken from... the way that the reason why they're named the way they are is because they were... I think it was Murray Gell-Mann, a physicist who worked on the Standard Model, took their names from characters from Finnegan's Wake. That's why I say Finnegan's Wake.
Oh, is that...
So it's an
that's a
actual
book?
book.
Okay.
Yeah,
It's the-
so
So they're
they...
just named after just...
It's the predecessor to Ulysses. It's, of course, one of the great English novels.
So James
God.
Joyce. That's why they have these, like... I mean, the 60s were a crazy time, man.
But it's just so, like...
Yeah.
You got up, down, top, bottom, but then charmed and strange.
Charm and strange, yeah.
Well, charm and
it is kind of
strange.
confusing, but I think it's better than saying, like, this is the A type, this is the B type,
Yeah.
this is the C type.
And
Clark
really and truly, all you need to know is that the entire universe that you can touch and experience and feel, I'm talking about like tables and people and all this kind of stuff and glasses are made up of up quarks, down quarks, and electrons. And that's it.
That's it?
That sounds
That's
like
all you need to know,
the
everybody.
ultimate building blocks of the universe.
Yeah, because anything that's heavier, and really and truly, when you look at these things, so up and down, and then I think the next one is maybe it's charm and strange. So I think top and bottom are on the end.
Yeah.
So up and down. So the next family is charm and strange. They're heavier than up and down, and so since they have more mass, they tend to not. They're unstable.
Oh.
And so they break down into up and down, and the
Okay.
same thing with top
And
and
it's
bottom.
the charm and strange quarks and the top and bottom quarks that we only observe or know through particle collisions in labs.
the
Large
Hadron
Hadron Collider.
and Fermilab and things like that.
If we were to visualize these quarks, for visual learners out there, how can we, like, what do they look like? How can we visualize them in our brains?
Oh shit! Well,
Can you?
That's a really difficult question, and it's really
That's what
kind
I'm
of
here
unanswerable.
for, posing the tough questions on Cosmos with
Because
Cosmos.
they're considered the way that physicists describe them is that they're called point particles, and so they technically really don't have any size to them, and so and so it's really kind of hard to. I can't think of a way to have somebody visualize it.
And it's not like you can think of them like in a nice cluster, like when you think of molecules, all these, the atoms are all built
vibrating
together.
together and just kinda like-
because these are points, and the distances are so small, but yet at the same time so vast within that small scale, just like little points. Little points, like little pinpricks, and it confuses me.
And so these quarks inside of a neutron or a proton are held together by they keep exchanging this thing called a gluon.
Boy,
A gluon that glues them
together. Yep.
see, that one makes sense.
Yeah,
Yeah.
that makes total sense.
And so if you were to take two quarks and you were to pull them apart,
Oh boy.
the energy that it takes to pull them apart actually grows. And so you can't actually ever pull them apart with the energies of the universe that we experience right now. And so maybe right after the Big Bang you could, but right now you can't do it. And so it's called confinement. And that's why you never have in the universe today, because the universe is too cool, it doesn't have enough energy, free quarks. They're just flying around. They always are connected to somebody else, to another quark.
Wow,
And-
free the quarks.
Free the quarks. And Katie just brought up a great point on the chat. When you think of these particles at this smallest scale, it is like a universe within a universe within a universe.
Yeah.
Oh no.
Yeah. It's just like that Men in Black scene when they go out of the universe and it's the aliens playing marbles with the
Oh, yeah,
galaxies.
yeah.
Basically that, but at smaller scales.
And this is just a quarks. You have this whole that's one family.
Oh yeah, there's other
You
things.
have you have the leptons, which are the electrons, and the electron. If you look at the electron families, they kind of mirror the quarks. So you have three families. Each one has two. You have an electron, and then you have the electron neutrino.
Okay.
In the next family, you have the muon, which is a heavier version of the electron, and its corresponding muon neutrino. And then you have the tau, which is even much heavier than the electron, and its corresponding neutrino. The problem with the standard model is...
I love that there's a problem with the standard model.
The standard model is amazing at being able to make all these predictions, and the physicists that came up with it, they all won the Nobel Prize, and it's just an incredible model. It is a true science, in a scientific way of talking about things, a theory, because there's a lot of evidence behind it.
It's like Newton's theories. Everything works the way it should, but there's still more to it.
Yeah, and so the fundamental problem with the standard model is that it doesn't make any predictions about... So the question is, why is the muon roughly 200 times heavier than the electron? Why is the tau 1,397 times heavier than the electron? It's just an odd number, for one thing, and the standard model doesn't make a prediction as to why those masses are the way they are. And that's why there's some deeper physics that's going on that maybe string theory figures out maybe there's something else.
Can we say new physics?
There's going to be new physics.
Love new physics.
When new physics is just physics that's always been there that we don't know about yet.
Yeah, well, that's true. Yeah. And so you have leptons and hadrons. So you have electrons and quarks, basically, is what you have. And then you have what's called the bosons, or gauge bosons, and these are the force carriers. So the gluons, photons,
the force carriers, the force wielders.
Okay.
Yes, these are the Jedi of the universe. So so gluons, and then they're responsible for the strong force, which is what keeps quarks together, binds them together. You have photons, which are responsible for electromagnetism, basically. And then you have the weak force, Z bosons and W bosons, which are responsible for the weak force.
So what I'm gonna do here, because I'm sure people's heads, like my own, are spinning right now.
Yeah, just like Charm and Strange and Top and Bottom, my brain is starting to just break apart.
So when we think about this tiny universe, it's not just these individual points. It's not a singular thing that the universe is built on. It is a populated forest of chaos occurring at this incredibly small level. And this makes up everything.
Forest of chaos.
Populated forest of chaos. Welcome to Cosmos to the Cosmos. So at this point, that is the base of what we know. Now, very likely, there is stuff that builds that as well. And at that point, it gets crazy and weirder than Charmed and Directions and things.
I don't know how more strange it could get.
We'll find out, hopefully, within the next 15, 20 years.
Strings are pretty strange.
Yeah, that's true.
We'll do a whole thing on string theory at some point.
We talked about it a little bit in one episode. I can't remember what episode we talked about it.
We tend to talk about it a lot because we always end up getting into these small segments,
that's true.
It's just what we do. So let's leave the particles where they currently are.
All right, so step one, foundation, particles. The quantum worlds.
Yes, and so you have the quarks and the leptons. So quarks, protons, neutrons, and electrons, and then those make atoms, which is the smallest possible elements of the periodic table, basically. The next step, and then you bring these atoms together, and they create molecules. So that's the next step up. So quarks and leptons, making atoms, making molecules. And then the molecules come together.
And they can make things like proteins and such.
Yeah, and bigger things.
Yeah, and that begins to give us the building blocks of life when you start getting to the protein level.
Yeah, the protein level.
The protein level. Excellent.
This feels like a Powers of 10 kind of episode. And so we're just going to kind of
Yeah,
build
we're just
up.
going up.
Yeah, but what if the Earth were just the size of a baseball? Like
Jupiter and Saturn would be the size of beach balls.
Oh my god.
And I think Pluto's a golf ball.
Yes. For those of you that are like, what the fuck was that? We had a planetarium show called If the Earth Was the Size of a Baseball, and we kind of scaled up, did a little play with scale and kind of that sort of thing.
So when we get to proteins, that's when you can start building DNA. That's based off carbon life. There's possibilities of having other types of life other than carbon, but we haven't found it. Like methane possibly based life, silicon based life. But at the moment, it's strictly carbon. And now we'll get into the familiar terms: carbon, silicon, methane.
Hydrogen,
helium, beryllium, lithium.
Well,
radon, neon,
the
lead.
Sort of
I feel like I'm supposed to start.
Plum bum.
Well, because after the Big Bang, and when you had molecules coming together, whatever, like you had hydrogen, helium, and like a dash of lithium, kind of.
Yeah.
And even just those three elements when they were first made, within I think it's first 2 minutes, that was 98% of all the elements had been created just right in those first 2 minutes. Because everying else. Go
13
ahead.
minutes.
13 minutes.
And there's a reason why. No, there's a reason why.
Lucky number 13?
Well, no. But, no, because it all has to do with the neutron. It all has to do with the neutron. My little tattoo right here. All has to do with the neutron. So the neutron has a half-life. And so a free neutron, just doing its own thing out in space, will break down into an electron, a proton, and this little W boson that does this thing. Also, a neutrino goes flying off. But
fuck these neutrinos.
Yeah.
Oh, neutrinos are cool though.
And the half-life of a free neutron is 13 minutes, and that 13 minutes is also related to the creation of lithium.
That's so cool.
Ooh.
Yeah. So
go lick a battery and think about that.
Yeah. So at the end of that 13 minutes, when most of the free neutrons were decayed into protons and stuff, that's when the creation of lithium starts to die out in the early universe.
And Nirvana fans say thank you.
Wow.
That's just but most everything else was, yes, made in the first 2 minutes, 2 or 3 minutes. But you still had a little bit of that lithium being created.
All right, so we got most of our elements made right there in the first 13 minutes. And let's kind of move another step up.
Okay.
So when you get all these elements together, they can start to clump up and create giant molecular clouds. And over time, these molecular clouds, due to differences in gravity, can start to clump up as well. And if you get enough of this gas and dust mixed in one spot together, the gravity becomes so much that it will collapse, ignite, and become a brand new star.
Yes, indeed.
So the smallest bits of the universe come together at a colossal scale to create stars. And then around these stars, you have these big disks, because the molecular cloud's still there. There's still dust and gas and stuff flying around it. So then that will begin to coalesce as well, around in the flat disk.
You know what's crazy, though? In the beginning, though, there were no rocky planets. If there were any planets that had to be made, it
took a while.
They all would have been gas giants.
Now,
I just thought about that. Yeah.
Now, why do you think that would be, Liz? So, no, we can piece this together. So the things that make up the core of Earth, a bunch of iron, right? There we go.
Yeah, okay. Well, yeah, because you need those heavier elements to make the rocky worlds, and you can only get those heavy elements from massive stars going supernova, because those massive stars, through their lives and their deaths, is the only place that you can make those heavy elements, because the star, you need these incredibly high temperatures and pressures to then have iron, gold, platinum, calcium, basically everything after
up to lead. So
everything after
up to iron.
Up to iron.
Yeah, and then everything else is actually created in the supernova.
In the supernova itself.
Boom.
Yeah.
And that was given to us, I believe, in a 1958 paper titled "The Synthesis of Elements of Stars."
Oh,
Love that paper.
Yes, I've heard.
Yeah, and so all these people who have gold rings on their fingers.
It goes deeper than that as well. Keep going. Keep going.
You know, they'll say, you know, these gold rings, they represent love because we're married and all this kind of stuff. And they're like, oh, we dug it out of the ground. No, it was born in a supernova.
Yeah.
Iron
A star died for you to have that ring on your finger.
How do we know? And I don't know. I'm just asking this because I don't think anyone here has an answer. But like in
Challenge accepted.
Okay. Well then, in a supernova.
Yes.
Okay, so star goes big bada boom. And you have like gold being made. We'll just use gold. How much gold is made? Like how much gold is made in that? And is it enough? Like how many stars need to explode in order to have a gold ring made from?
There is an answer to that.
Amount.
There is an answer. I just don't know it.
You probably just need one supernova to happen to make enough gold go into a ring. I don't think that you have to have a gazillion supernovas happen to create all the gold that you have in the Earth. Because I mean, these are big fucking stars that are massive.
That's a technical term, mind you.
Yes. I mean, we said it all the time in college. Big fucking stars. It says it in textbooks. But
BFSs, big fucking
and
stars.
so big fucking stars when they explode, there's a lot of raw materials to make that gold.
But when it explodes, I mean, you have it all going.
It scatters.
So it scatters
out, and then it has to.
Okay, but that's not what you asked.
No, I know.
That's not what you asked,
No.
and so it does scatter, and so it goes off in different directions. Now you might need a bunch of supernovas to actually occur to see
to have enough gold to coalesce, basically come together.
I mean, because think about it. I mean, think about it. A star goes boom, creates this gold. It goes off in all directions, by the way. And so you need some of that gold, just a small fraction of that gold ends up in a molecular cloud, which then collapses, and a very small fraction of that ends up on the Earth or on a planet. And so it's a fraction of a fraction. And yeah.
And Mike just hit on something else I want to talk about too. He said when the star explodes and it goes into another molecular cloud, so when the star will explode and it sends its guts out through the cosmos, it will oftentimes hit other molecular clouds. And when that happens, that may be the trigger point for a new star, a catalyst, for a new star to be born. So that's exactly how our star was born. Is a supernova went off nearby somewhere, and it collapsed our own molecular cloud and ignited our sun.
Yeah, I think compress might be the better word.
Is a good
it
word.
compresses it, which then leads to the collapse. And so, yeah, I mean, it's just an amazing. The universe has got a fucking amazing story, and it's you don't need a god, but it's just absolutely amazing that the universe existed for what 8 billion years before our sun even arrived on the scene, and then what 5-6 billion years ago our sun starts to collapse down. I mean, the molecular cloud starts to collapse down and creates our sun, and then basically 4.5 billion years later we arrive here on Earth.
About ready to eat some pizza tonight.
Oh,
and then you were born.
You were born.
4.5 billion years ago, the formation of Mike George began.
I was
71 years ago.
Oh, that counts.
Oh, that's a drink.
That's a drink.
Well, okay.
All right. So,
and speaking of my birth, I need to talk to my mom. I need to know why she couldn't wait just 1 minute. I was born at 5:59 p.m. So
That's fucked up.
Gotta get it right.
I mean, couldn't the doctors just say, "Hey,
you're round up"?
Yes.
He's gonna mess with his kid's OCD the rest of his life.
Don't make my mom just stop mid-delivery.
Liz, do you know the exact time you were born?
Oh, okay. Well, my mom's on, so I think it was like 7:10 p.m.
Oh, wow.
On a Monday, or around 7 p.m.
Oh, wait.
On a Monday.
Are people supposed to know the exact time they were born?
Well, I've asked.
It's on your birth certificate.
I know that.
And I'm pretty sure. I want to say most moms. Know the time.
ends.
Because I mean, they're being ripped
Yeah.
open in one way or another.
I know
so it's
they know the time that the pain, quote unquote, ends because it doesn't end. But you know.
Wow. I mean,
I was right.
Yeah.
I was right.
I mean, I know the day I was born.
Well, I'm glad you-
Not the weekday, mind you.
The
Just
date.
the day. Just the
The
date.
date.
Yeah.
I think mine was a Friday.
Yeah, I think
Oh,
mine
my
was a
goodness.
Monday.
Okay, so let's.
Oh, look, Jack knows.
Hey,
Wow.
1, 2, 3.
Everybody
I
knows.
guess this is
Oh,
a.
that's nice,
That's
Jack.
nice. Yeah, that's cool.
You need to figure this shit out
I
by the
know.
time this episode ends.
Call your mom after this episode.
I
Find out
called
what
her
time
already
it
today. She was having
And-
a nice walk and flex.
Just
And
text her.
did you tell her that you loved her?
Of course I did.
Okay.
Good.
Of course
'Cause
I
you
did.
don't
I
every
always
time.
do.
No, not every time.
I always do.
Not
I
every time.
disagree.
She was just calling me for a quick question, and she said bye, and I said bye. Is how it worked. Anyway.
Could have died of those mountains.
Always tell your mom you love them.
Anyway, where were we?
So we were talking about building blocks of the universe. We were just mentioned how the sun was born, and how
Yes.
gold was made, and other stars, and how it
Yes.
helped coalesce into our sun.
So gas is the building blocks.
Gas.
Yeah, gas, just
Yeah,
like
and
gas
it's just
is
like
the-
dispersed gas. Like
Yeah.
it's just gas and dust and
That's just like Leia.
it's just like
Oh
land.
God. Oh, God.
Puppy dog Leia, not General
No.
Leia Organa.
What are the building blocks of things like Earth and Mars?
Well, gold is one of them.
Iron.
Yeah.
Iron.
Iron.
Iron is a big.
Carbon.
Dirt stuff.
Dirt shit.
Dirt shit. Yeah.
Do all because iron. I don't know. This might be a question.
Yeah,
I'm sure.
It was leading that way.
What percentage of planets that we know of?
Okay.
Rocky planets have iron cores. Is an iron core
Well,
kind of the standard, or are there
Yeah.
other
Iron,
elements
nickel.
that can
So they'll
be?
they'll always have iron nickel core. Whether or not they're rotating and heated up is another question. Like look at Mercury, it's cooling down, but Earth's still
Yeah.
going thanks to Theia colliding with us a couple years
Well,
ago.
and Mercury's a lot smaller.
Also true.
So-
They'll always have the heavier elements down below because they're synced down to the core. Sorry.
Yeah, I'm sorry. I was reading Jack's.
We were reading Jack's comment.
I was reading Jack's
It said
comment.
Mike's carbon might have been in a dinosaur or redwood previously. That's another thing.
Or was it dinosaur poop?
Oh, I'm
That was
probably
then
dinosaur.
that was then
Probably
eaten
dinosaur
by a
poop.
redwood and eventually became Mike.
How's the redwood eat the dinosaur? Oh,
Comes
fertilizer.
fertilizer,
Duh.
So trees eat dinosaur poop.
You know what? I'm fine if it was dinosaur poop. That's pretty cool.
Yeah, circle of life shit.
There's this, I forget the exact phrasing or the calculation behind it, but we all breathe in the air and exhale, that as
Oh, yeah,
well.
yeah, yeah.
So, over a given amount of time, all the air, if
Twilight.
you breathe it in somewhere on Earth, has been breathed in by, William Shakespeare, for
Oh,
example.
yeah.
Like Alexander the Great,
Yeah.
just based off
Yeah.
how much breath they took. So
I think
that's kinda cool.
it's every breath you actually have.
Every breath you take.
I think that is one of the greatest
Nicely
songs
done.
ever. It's one of the greatest songs ever. People play that song at their weddings. It's a song about stalking. It's a stalking song.
Okay, so this is a rabbit hole.
Welcome
I'm
to
going to bring us
Cosmos
back
Cosmos,
out.
everyone.
Because this is a rabbit hole I was about to jump into.
Okay, well, Joe mentioned by trilobite.
Trilobite. Oh, I love my trilobites.
And my mom says, we're all part of everything past, question mark. Yes!
Yes!
We're part of everything past. Everything.
It's
like
the
all
circle
of
of
everything.
life.
All, the entire past of the universe. We're part of that.
Yeah.
We are.
Who knows where...
We are the cosmos.
Who knows
Oh,
where in the
ready?
universe all
Ready?
the gases came
Ready?
from to...
Ready?
Yeah.
Ready? So as we are the cosmos, we are a way for the cosmos to know itself.
Ooh, Carl Sagan. Well done. Well done.
Okay.
I bet
All right.
he waits every show for an opportunity
Oh,
to say something like
okay.
that.
I need to. I'm gonna give you a little edit break here. Okay.
Okay,
so
well, give me an edit break so I can pour some more
Oh,
drink.
yeah, let's do that.
Because you hate the sound of this.
I do hate the sound of it.
So I'm just gonna... Here, I'll do it over here. He doesn't
With
like
my
the sound.
Long Island, my milkshake.
All right. The reason why, because I don't want Joe to go somewhere, and I just want to say, Joe, you need to be on the podcast. So we need to figure out a time for you to
And-
be on the podcast.
It's only been a couple of days since I saw you, Joe, but I miss you.
See, we told you he would love him. Joe's great. Joe, you're amazing. We love
Yeah,
him.
we told Brandon.
Oh,
that,
by the way,
We're like, Joe's the best guy.
Yeah,
So,
and you're gonna love him. He's gonna treat you right.
and we went to the Baseball Hall of Fame together.
Yep.
God,
Guys
the
went
way
on
to
a
Brandon's
date.
heart is baseball.
Oh my god.
Sports ball.
Yeah, we Oh, he misses you too.
Aw,
He never says that about me.
it's gross. He misses you.
No, he misses you.
Misses
You and
anyway,
Brandon.
Anyway,
But
anyway,
anyway,
Ed, break over.
Yeah, so when you come out for Doug, we should do a podcast.
Oh, we have to. That'd be great.
Okay.
So,
Yeah.
All right.
but that's a billion months from now.
Pause.
Okay. He misses you all the time. God.
All right, back to the show.
I gave us pause.
Yes.
All right, so we talked about the building blocks of the Earth and life. We got really deep with stuff with the cosmos. So let's go one more step of a building block.
Oh, okay.
So we got to solar system scale. What about universe? Or, galaxy scale. Sorry,
Yeah,
galaxy
I was like,
scale.
we're already
Wow, we're skipping.
a galactic
A galactic scale. How much does the Milky Way weigh?
Well, it's made
200
of
billion
breast
stars.
milk. We've learned
That's
in a previous
right,
episode.
in the previous constellation episode. So, with the guts, the stuff that make up a galaxy. First of all, what exactly defines a galaxy? Can you just have a couple of stars thrown out there in the universe, somewhere in the aether, and call it a galaxy? Or is there a certain threshold where it's, okay, I have 6,000 stars, I have 6 million, 6 billion. Like,
That's a good
what's the
question.
threshold there?
That's a good question. I
Is
don't
it
know
the
the answer to
shape
that.
that you have to have in
Well,
a regular?
I mean, it
no.
has to be a certain size because you do have large clusters of stars, globular clusters.
Which is about 100,000 stars. Roughly.
So
Yeah.
you need to have, I think it's these larger structures of stars, and some gas and dust. Not all have a lot of gas and dust, but
What if it's like the Supreme Court said that pornography is that we know it when we see it?
maybe, yeah, we know.
Yeah.
But it could be art. So
All galaxies are.
Well, yeah. I mean, I do think that there's probably somebody's probably got a minimum.
yeah, I'm sure there's like an
thresholds.
actual.
Yeah, and so I mean, because you could say like, let's just take the biggest globular cluster that we know of. I think, which is like maybe M13 in Hercules,
Yeah.
Yeah.
which I think has about 1 million stars in it.
Okay. Yeah.
And globular clusters, if you think of a collection of stars in the shape of a basketball, so a spherical collection of stars, they actually kind of orbit galaxies, like orbit the Milky Way and stuff like that.
Yeah, they're
And we-
usually
and-
like out of like in the halo.
And
of
the,
a
the
spiral
Milky Way will
galaxy.
act like Pac-Man to eat them over time.
Yeah, and these are some of the oldest stars, really, kind of in the universe. And if you were on a planet, let's say hypothetical planet around a star, you would have no night, pretty much, because towards the center of this globular cluster,
Wow, that's something to think
because
about.
you have the star, and then you have like the Hercules globular cluster M13. You have like 1 million other stars.
So-
500,000 other stars at night.
mean,
So it
So-
just explodes with stars.
Perpetual sunrise.
Perpetual sunrise, yes. And not only that, if you're able to actually see it, the Milky Way.
And you'd probably be dead, but doesn't matter.
Yeah, because the
Oh,
it'd
radiation.
be
number
the
one.
radiation and
Yeah.
the heat would
So
be.
let's put
less.
you
Those are synonymous.
astronomical.
So let's put you at the edge of this globular cluster.
Let's do
Okay.
it.
And so you actually would have night if you are on a planet. Then
my God.
you would have you would see your sun, your star,
Okay.
but then you would also see the Milky Way. What an amazing view to
And that one star you would have will be accompanied by 1 million others.
Okay,
Oh, we're gonna get back
we're
there.
gonna get
Yeah, let's
off of
digest
this.
this.
We're
Yeah.
gonna get off this. We're already off of the main topic, but okay, if you see the Milky Way though, but it's not like because you're not in the disk of the Milky Way, so you're not seeing it like we see. You would see the
Yes.
Milky Way.
You
You'd
would-
see the
yes.
bird spiral.
You would see the core. You would see the spiral arms. And what an amazing sight to
and
see.
that's why they're looking at their own galaxy at the end of the Star Wars, the second one.
Now, Hercules cluster still counts as in our galaxy, so they're still in that galaxy. This is a point
Yeah,
of
but they can see
contention
the
we've
whole
had many
galaxy.
times,
So
indeed.
they're looking
Still
at their own
inside.
galaxy. I made a Star Wars reference, so we'll drink
Yeah,
it.
and it's
Oh.
at the end of Empire.
I
Okay,
couldn't the names.
Yeah.
I was like,
wrangling
I know
us
what you're
back
talking
in.
about.
all right,
That's
wrangling
your
us
job,
back
man.
in.
Wrangling
That's
us
your
back
job.
in. That's why I'm here today,
It's the
guys.
job of the host.
Okay, we were talking about globular clusters. So galaxies, that's right, galaxies.
building blocks.
Building
Go into
blocks.
galaxies.
So there is some kind of threshold, I'm sure, as to what defines a galaxy.
Mm-hmm.
But most big galaxies definitely have at least one thing in common, and that's the object in the very center of their galaxy.
Mm-hmm.
Liz got excited. Go for it.
supermassive black hole.
Supermassive
Also called
fucking black
what?
holes.
Well, for ours, Sagittarius A star.
And also known as cosmic dragons.
Ooh, that's right.
That's just black holes in
Cosmic
general
dragons.
are cosmic dragons.
Go watch Black. Anyway, so why? Why do galaxies at a certain size always have always, I'm gonna take that back. Mostly have a supermassive black hole in the center of the galaxy.
Okay, well, why? Because if you think about the building blocks of a black hole is a star, a really super massive, huge ass motherfucking star.
Damn.
That went supernova, but its core kept collapsing down over its own immense gravity, that it turns into a single mathematical point. Mathematical. But then to get a supermassive black hole, you need what? Like multiple black holes that then form into one and collide into one?
There you go.
Yeah, so
how do you get that at the center of a galaxy?
If you think...
If you need
so
stars...
let me go first, and then Mike will correct me when I get wrong.
Because right.
I'm just hypothesizing at the moment as to how these...
Well fucking done.
as to how these supermassive black holes get formed in the center. So, if you look at Sagittarius A star, we have about, 2 dozen huge stars orbiting it.
Yeah, and you can see their...
Yeah, you can actually see it.
You can actually see it.
It's fascinating. Okay, really quick, guys. Just go Google Sagittarius A star time lapse, and you'll see stars actually orbiting this supermassive black hole, cool. And it's the coolest thing ever.
And the images that were we took them within our lifetime.
Yes. Since it's like 96 to current day, and you can actually see them go around. It's fascinating.
Yeah. So when you go out at night, the stars seem eternal. They don't appear to move, but we can see these stars move within our lifetime. But anyway, continue.
Okay. So you have all these massive stars.
Okay.
So clearly, if there's that many stars near the center, because that's where everything's going to be orbiting all this mass, over time, then a black hole would, I'm going to say, induct these stars into its family. Basically swallow it up and become more massive. So I would hypothesize then that over a long duration of time, that black hole would just constantly be eating other stars and get to the size of Sagittarius A star and other black holes as well.
But how does the black hole get into the center of the galaxy? So what comes first?
The chicken or the egg?
The chicken or the egg. The galaxy or the black hole?
So first of all, it's the egg comes first.
The egg always comes first.
Yeah. But in this case, I can't think at the moment due to Cosmos and Long Islands.
You can say you don't know. It's fine.
No, it's fine. All right. So, but you're right. So the supermassive black hole grows in size because it is
it's hungry.
eating up. It is hungry. It is eating up.
Hungry black hole.
It is eating up other stars. As these other maybe smaller black holes orbit this larger black hole at the center of the galaxy. They give off gravitational waves, which makes the orbit of that smaller black hole decay and actually falls into the black hole. And that's why LIGO is such an amazing thing. But so yes, they grow over time, and that's why if you look further back into the universe, what do you see? You see quasars. And when you look at quasars...
Quasi-stellar objects.
Radio objects, yes.
Yes.
So they're very bright in the radio wavelengths. And so when you look at quasars, you're looking not at the galaxy itself, you're looking at the core of the galaxy. You're actually looking at a black hole that is feeding.
Chills!
Yes.
Chills!
A feeding black hole.
So
here comes the star.
So when we look at our center of our galaxy, that's is great. I'm visualizing a galaxy parent feeding
a black hole with supermassive stars. Yes.
Yeah. So when we look at the center of our galaxy, and when we look at Sagittarius A star, it's quiet. It's not feeding. The things that fall into it, and we get excited when, oh wow, something has just fallen into this black hole because we can actually kind of see it. We get all excited, but generally it's quiet. But if you have somebody on the other side of the universe right now looking at the Milky Way,
they're not seeing it at the same time.
Yeah.
Yes, they're looking at it as
when
it was
real
feeding
hungry.
13 billion years ago.
13 billion years ago, the little tiny baby Milky Way galaxy.
We always look into the past.
So yeah, but how did it how did it get to the center of the galaxy? Kind of did it? I don't know.
It is, yeah. I mean, whether this black hole initially started there, it's probably not.
No,
it just kind of migrated there.
Like a snowball. Thinking of it, it's like a snowball. As one thing gets bigger, other things are going to slowly attach onto it over the long duration of time. And when you're forming over 13 billion years. A lot of things are going to slowly attract to you, like the Hercules cluster.
And you're going to end up in the center. I mean,
Yeah.
it's like the iron nickel core. The heavier things.
Oh wow, okay. See, that
Yeah.
makes sense in my brain. All right,
Yeah,
okay.
they migrate to the center.
And that's why
of
it's
the
so
planet.
consistent that spiral galaxies have these supermassive black holes
Perfect.
at the center of them.
And so that's going to be one of the major building blocks of the Milky Way galaxy. And our galaxy is that supermassive black hole.
Yeah. And so our Milky Way also, well, I mean, you can say our Milky Way, but other galaxies are consuming other galaxies in what we call it.
Galactic cannibalism.
Yes, indeed.
Now, for those of you on the podcast, when Mike said, "What do we call it?" both of us pointed to Liz because that's like her favorite phrase.
It's my favorite scientific term, galactic cannibalism.
Yes, and so the black hole at the center of that galaxy actually ends up in the feeding into the black hole
yeah.
at the center of, say, the Milky Way.
Yeah.
And that's what's going to be just an amazing thing when
Andromeda-
Milky Way and Andromeda collide. Is they're gonna do this little dance.
But they're gonna merge.
They're gonna merge. Yes.
Yes.
Yeah, they're gonna do this dance, but those black holes are gonna collide one day and make it even bigger, supermassive.
And
black
the
hole.
waves that will be sent out
I hope
from
somebody
that.
has a LIGO way out there in
Yes,
the universe to
absolutely.
detect
They're gonna
those.
see
Okay. So that's kind of the building blocks of our Milky Way galaxy.
Okay,
And all
alright,
galaxies, black
alright.
holes, stars, planets, stuff, becoming more massive and giving us a shape.
Uh-huh.
We're going to kind of skip the superclusters. So the Great Virgo supercluster, it's a whole bunch of galaxies kind of structured in this fascinating type of shape, just in the interest of time.
Okay.
And we're going to take a big step and talk about the building blocks of the entire, I'm going to say cosmos. Not just the universe, but the cosmos.
Isn't the universe the cosmos?
No. No, it's not. So, really quick. So you can break down the universe. Universe, of course, one, and one reverses existence. So one existence, I'll call it. But the cosmos is all that is. So if there's more than one universe, that's part of the
multiverse.
cosmos. The multiverse. Let's go find Lokis.
Oh, well done. Well done.
So the shape of... Okay, we have no idea what the shape of the cosmos would look like. I'm sure somebody has some kind of crazy theory.
There's still fucking debate. Oh, the cosmos.
Yeah.
I was thinking the universe.
The shape of the universe, we
it's
have
a
ideas. It's donut shaped.
We watched some bullshit
Okay,
video about
yes.
Tauruses, so that was an inside joke.
If you're looking at anything on YouTube and they talk about Tauruses in the universe, just skip it. I had to walk out within the first few minutes. It just pissed me off.
Anyway.
So when I think of the shape of the universe, the structure of the universe, I'm going to think of the cosmic microwave background.
Yes.
Does that sound right to you?
Mhm.
Okay.
Mm-hmm.
So this is a snapshot of the universe.
Not that kind of Taurus, Katie. Taurus, the shape Taurus, not a Taurus as in a Taurus the bull.
Oh, is
Or-
she Taurus?
She's
or-
a Taurus, so.
Or Taurus the Pokemon.
Or
There's a big
that.
difference. You can only capture that within the game. Anyway. So the cosmic microwave background is basically a snapshot of the universe and where the mass, where the galaxies currently are. And so you can see where it's quote unquote hotter, it's where the stuff is, and a little cooler where there's less stuff is. And when this was first taken, this was called the face of God, because it was the first time we can actually see the entire universe.
Can I? How old is the universe when that snapshot is taken? Because I think we should tell them.
Wasn't it about
300,000 years old.
300,000 years old?
Yeah.
Okay.
And it was actually at the point where it was the moment in which the universe cooled enough to where you can have photons freely fly out into the universe without running into another atom.
So that picture then is not pictures of galaxies and massive stars and planets and civilizations. It's a picture of the smallest things, of the electrons, of the light. And so once again, we come all the way around from particles to planets to galaxies to the superstructure of the cosmos to individual points yet again. One of the weird things of space is the larger you study, the smaller you have to know. Just like Mike was saying. You'll have to know those point particles, those electrons, those leptons, as you want to study the structure of the universe.
The largest thing that we know of, the cosmos, is made of the tiniest shit. Yeah, I like how he was going real nice and with real pros and stuff, and then I come in.
It was
if he asked me to repeat it, I wouldn't know what I just said.
So Brandon's being the Carl Sagan, and then you and I just bring it down to
the everyday common folk level.
I like having
made of
fun.
small shit.
It's made of small shit. So the big things made of smaller things, made of smaller things, made of things we don't really know of in that chaotic, forest-populated area. Whatever I said earlier.
Yeah, chaotic forest.
Area. It was nice. Now, of course, I think we should all join us for the hangover up next as we discuss what the structure of the cosmos, of the multiverse may look like.
Is that what we're discussing?
Yeah.
The hangover?
I just decided.
I guess so.
I have
all
spoken.
Right.
Okay.
Is that are you closing it out? Are you closing it out to go into the hangover?
Yeah,
then?
that's what I was doing right there. We've
Okay.
been on a good long time, and this is a great time. I loved every moment of it.
What if I want to talk about pizza?
The building blocks of pizza. Well, first of all, you got the good dough, right? And the dough is going to depend.
No, this is for the hangover.
Oh, okay. It's going to go in types of yeast.
Well, first, to make a pizza, you gotta make the universe.
Gotta make the universe.
All right, folks. Thank you so much for joining us as we discussed everything from apparently pizza, the point particles, to the galaxies and the cosmos at large. Join us for the next show as we discuss
space weather.
Wait. Space weather, or is there a more specific title we had?
Oh shit! What was the title?
Space tornadoes.
Space tornadoes.
And it's not a question; it's an exclamation point.
Yeah.
And we do want to thank Liz's mom for this topic.
Yes, topic contributed by viewer. My mom.
All right. So for those of you on the podcast, thank you for joining us. Have yourself a great, safe, long time. For those of you on the YouTubes, stick around. In a few minutes, we'll go to the hangover.
Yeah. So we'll take a short break now, and then we'll see you guys in a few minutes with the hangover because we gotta refresh.
And make more drinks.
We gotta make building blocks of the hangover.
Building blocks of the hangover.
I need to eat something.
Hot.
Yeah, that'd be nice.
That would be good. All right, we'll be back.
Cheers, everybody.
Deuces. Welcome back to Cosmos with Cosmos Hangover Edition.
Woohoo!
That's all. We just got a big message on the chat. I had to read it and I got thrown off. But that makes sense. What was just said. You can't have too much chocolate; it will throw you off.
No, you get that sugar crash later.
No.
We got homemade, courtesy of the birthday boy himself.
Oh my god!
Banana pudding and peach cobbler.
Peach cobbler.
Which
It was
turned
my
out,
first time baking.
and you did a great job. It turned out it tastes really good.
Oh my god.
It was, yeah. Oh, thank you.
Yeah.
It was my first time baking, and I see more peach cobblers in my food.
Yeah, the funny thing about baking, it's an exact science. It's not like cooking. We just throw stuff together,
you
and
just kinda-
it's not an art. It is a science, and that happens to be what he's fantastic at. So there's more baking apparently in the future.
Yeah.
I think so.
Okay.
Yeah.
Baking and making drinks.
Baking and making drinks. All right, so we wanted to talk about bigger structures of the cosmos, structures of pizza, things like that.
Yeah, okay.
But I kind of want to start with something different. So we had just finished up the Loki finale, which of course deals with the multiverse.
So no spoilers though.
No spoilers.
No.
No spoilers. But Liz had posited us a question.
Oh, are you doing that?
So let's get into that question. Yeah.
Okay, well, my question was, is the Big Bang, or would the Big Bang be considered an apocalyptic event?
Would the Big Bang be an apocalyptic event? So or
other Big Bangs?
Yeah.
Or
At first glance, you would say no, because the first Big Bang, the
came
Big
before
Bang,
everything.
well, the Big Bang itself created everything. So it would be the opposite of the apocalypse.
Yeah.
It would be
And that's how I would define it.
right. Yeah. So that would kind of make sense. However, with the multiverse theory in play here, we don't know what caused the Big Bang. What came at T equals
Yeah.
minus 1 second.
Was it an apocalyptic event
Yeah.
for another universe, for our Big Bang to start our universe?
I'm
Yeah,
going
I don't know.
my gut, because my gut's part of the cosmos, and the cosmos
Your gut can't
knows
be
itself.
trusted.
It cannot be trusted.
No.
No, but I would say no, it wouldn't be an apocalyptic event, just because there are so many other possibilities of how a Big Bang began. But it is very possible that the Big Bang began when a supermassive black hole swallowed up something, and we had talked about the universe of point particles, the universe of infinitesimals.
I think Fancy Physics Man has some words.
Well,
Oh, I'm going pure science fiction here, folks.
Yeah, that's.
Oh,
I'm
okay.
going pure science fiction. So we have a universe of point particles beneath everything we see at the moment. So in some weird science fiction deal, if a star or what have you got into a black hole, then there's incredible infinite amount basically of point particles that have now been thrust in this black hole and go somewhere. Maybe they created the Big Bang within those black holes. We don't know.
That's true.
Now, another part of when we were discussing this was, okay, so say this isn't going to happen in our universe because our universe isn't going to experience the big crunch, right? We're going to
Alas.
experience the cool, the whatever, the deep freeze, whatever it's called.
Heat death.
Heat death of the universe.
Wonderfully poetic way to put it, yes.
But if we were, if our universe was to experience a big crunch, so that's where everything basically falls back in on itself. I think I remember learning that big crunch can actually lead to then
A rebound.
A rebound, which would be a big bang. So that big crunch itself would be an
It's all
apocalyptic event.
hypothetical. It's all hypothetical.
Well,
But so when you rebound, of course you would rebound back out and crunch back, and so over time you would lose energy because of entropy. I'm assuming on the cosmic scale like that. So eventually it would just rebound to smaller and smaller level.
You lose energy. Okay, so my question would be, where does that energy go? I mean, is because thermodynamics.
you can't. Energy has to go somewhere.
Energy can be neither created nor destroyed. So it's not that the amount of the energy of the universe is constant, and so in a closed system, which is what the universe is, and the only way that the universe can lose energy is if it is losing that energy to another universe somewhere, and how is that connected, and all that kind of stuff. And so it would be like the perfect just rubber
accordion,
band,
giant accordion.
It'd just be like an
Yeah.
endless slinky.
Yeah.
Science fiction idea. during a big crunch of a cosmos, of a universe, a advanced civilization attempts to stop it.
How?
I don't know.
That actually, I mean, yeah,
That'd
that's
be
a good
kind of
premise.
cool. Yeah, I'm up for that.
But it's an apocalyptic event.
It would be.
Mm-hmm.
So yes. All
Okay,
right.
well, there you
we
go.
go. That didn't answer anything, but it was fun to talk about. So now let's take a huge, massive, apocalyptic step back and talk about the structure of the cosmos. This is all the multiverses, should they exist, which at this point we're assuming they do.
Well, we can't assume.
We-
You know what? If you assume, that just makes an ass out of you and me.
Boom, well done.
Unless in a other universe, an ass is a good thing, and then it's like, hey, let's assume, because it's a good thing. I don't know.
No, you can't.
Well,
You can't word your way out of it.
if string hypothesis is correct, then yeah, there has to be these multi-universes. Multiverse.
Why wouldn't there be other Well, I don't know.
Because it doesn't make sense.
This is where my brain
and,
just starts
and you
to
even
kinda...
have like the quantum interpretation of one of the interpretations of the Schrodinger equation, where you would have these multiple universes. And
Cat is both alive and dead. And there are multiple cats.
Yes.
And maybe a dog.
Just
Maybe a
like
toaster.
I think that
Brave little toaster.
life here on Earth is not the only life in the universe.
No, statistically speaking.
That's a whole we can dive
I know,
into.
but I'm statistically no.
I just feel like there's got to be other universes out there. But that's a gut thing. That's not science.
I guess you have to then you have to distinguish your definition of universe from universe. Because when I think of universe, I've always thought of the universe is everything, whereas I guess you think of the universe as this is just our universe, our house,
which
where
goes
there could be
to
multiple
Brandon's
houses in the neighborhood.
Goes to Brandon's
Of
definition
the
of
cosmos.
cosmos.
Because to me, universe and cosmos were always synonymous because
Yeah.
in my brain, the universe was all.
Okay.
Mm-hmm.
So when I think of universe, then I am thinking of, lack of a better word, an area instigated by a singular Big Bang. Now, there may have been other Big Bangs. There may be Big Bangs running currently. But those are separate universes due to their origin points.
And universes were all self-contained, so everything is within that universe, and everything in universe B is within that one, and you don't talk to these others.
Unless there is a universe that bumps into another universe and creates a cold spot in cosmic microwave background.
Yes, exactly.
Love it.
And they're looking for that, among other things. But they and that's why, I want to say, a couple of years ago, there was a physicist, astronomer, researcher, whatever, and she saw some patterns within the cosmic background radiation.
You know where that was at? So I don't know if this was the exact person that found it, but this was the person that was talking about in Chapel Hill.
Oh, North Carolina.
Oh, okay.
UNC,
yeah. She was
and
talking about it there.
and they saw some patterns within the cosmic background radiation, which is that picture 300,000 years after the Big Bang that Brandon was referring to in the actual podcast.
Yeah.
But I mean, it hasn't been proven.
No.
And so
how can you prove that?
Well,
How can you prove that? That it's not. I don't know.
Yeah, it reminds me of this thing that Liz and I watched, where it was this physicist that was answering questions, and he was talking about the cosmic background radiation, and somebody saw these patterns, and they were like, "Oh, that's proof of gluons within gravitons.
Gravitons.
Proof of
Oh, there we go.
gravitons. Proof of gravitons. This is the pattern we'll see," and it turns out it was dust. Dust in the
Well,
universe.
It's always fucking dust.
Fucking
Look at
dust.
you, Beetlejuice. It's
Gets
always
everywhere.
dust.
Yeah, and so, you have to rule out pretty much everything else when you see these patterns, which is difficult
you can't
because
really do.
we don't know
You don't
everything.
have all the information to rule.
Yeah, and
everything
so
out.
it could be lots of things. It could be as simple as dust within the universe in the case of the gravitons, but
What kind of proof, evidence, data is needed, experimentation, I don't know, is needed to then prove or validify a multiverse hypothesis?
Honestly, if you had a being from a different multiverse reach out,
Okay, so that
punch a scientist in the face saying, "Here I am, motherfucker," that still would not be enough. Because I'm assuming in different Big Bangs, different scenarios of Big, they would have different physics. Because our physics works in a very certain
that's
way.
a good point.
So in the events where a different multiverse reaches over to ours, their physics was break or our physics was break.
Let's talk about different physics. What could they be?
Everything. If physics was slightly different, then our universe would not exist.
and we're not talking just okay. So you're talking like say the gravitational force is slightly stronger,
right?
Or even like slightly weaker, or the electromagnetic force.
Planets wouldn't be here.
Yeah.
Civilization would never occur.
Or the strong force slightly weaker, which means you don't have as many elements on the periodic table in this universe. Let's say the strong force is hypothetically half as strong as it is in this universe. Well, you might have only about half the number of elements on that universe's periodic table.
Wow.
Let's say that the electromagnetic, not the electromagnetic force. I'm going to say the weak force has a strength of 0. That means you do not have any kind of nuclear decay. So uranium, if you even have it in that universe, is just an inert element. It doesn't have any radioactive decay on it or anything like that.
It's not responsible for death
No.
and destruction and cancer.
Yeah. And so if gravity is stronger, that has definite implications for the creation of stars and all that.
As we understand it, because in this different universe with different physics, of course, it could be completely different. Where instead of stars, you have massive triangles in the sky, what have you.
Well, that would take a lot of energy to make triangles.
How the hell do we know in a different universe with different physics? So as you were talking, I was thinking of this fantastic philosophical point. It's like you have a deck of cards, and you draw any one of those 52 cards, and you pull out the 7 of spades, for example. And everything in the 7 of spades is all you know. So in our universe, physics is all we know, so the 7 of spades has to be right. You can't really imagine what the other cards would look like, because you're not that. So the idea here is that the universe is perfect. It exists the exact way for humans to occur, and they get down the religious road. But then you bring up this deck of cards idea, and you have the 7 of spades, but then somebody else is the Queen of Hearts, for example, and it works perfectly for them. So it's just whatever universe out of an infinite amount, and if you have an infinite amount of universes, there's going to be an infinite amount of possibilities for.
Right. Yes. But there are certain cards in this metaphor.
Oh yeah, that would just have no sense of being.
That would
Jokers.
have no life in it at all within that universe, and like you might have certain cards where stars do not form at all. In that universe. Now,
in this regard, we also need to be cognizant that you don't, in some unknown physics, you may not need stars for a semblance of life, but. You would need something to keep structures together, I would assume. If you can't have, some points of matter that would coalesce together, you eventually cannot have life, I would assume.
Okay, here's my thought, and I don't think this is going to really come across clearly.
Okay.
Physics is physics across universes. And so physics is physics across universes. However, the constants of those of that physics will be different across universes. Yes, you'll have universes that will have the exact same constants as, like the gravitational constant will be the same as our universe, and so forth and so on.
Perfect.
However, physics is physics, but the constants will be different, which have definite implications for the evolution of those universes.
Okay.
So
does that make sense?
It does. So
Okay, cool.
to bring that metaphor down here, the United States has one set of laws. Canada has one set of laws. Saudi Arabia has one set. Australia has one set. Each country has an individual set of laws. So it's kind of like that, but with the universes. They each have their own set of laws
And
that
some
are
work and
constant
some don't.
throughout. Some work and some don't. Some are a little, fuzzy at the edges there, but they will each have their own sets. So in the same set as countries govern themselves, universes also govern themselves by their own current physics, which we have no idea what they would look like.
To get to the question from the audience here, so do you think that for things to come together on Earth to support or begin life, random?
Wait.
It is random.
It is random.
It's random. Okay.
It's a chaotic force, remember?
There is no God, people.
It's the clockmaker, the watchmaker.
Yeah, but quantum destroyed the watchmaker.
So. Get yourself a new job.
It killed the watchmaker.
Quantum was like, hold my beer.
Yeah. No, it's completely random. It's completely random. It just so happens that we live on a planet that is the right distance from a star.
But
that
anything could have
has
changed
the right temperature, has the right
at its current time.
Yes, has the right energy output in which to support life as we know it on this planet. It does not mean that there is a God that has created life here, and it definitely does not mean that this God created life 4,000, 6,000, 8,000 years ago, whatever the fuck
and
it
life
is.
on this planet has gone through many different iterations.
Before it even got to us.
Hashtag trilobites.
In fact, we wouldn't even be here if it wasn't for, a random impact that wiped out the major dominant species on the planet so that the little guys could
The universe is... How the quote go? The universe is crazy.
Crazy, cockeyed, and extremely weird.
Weird.
And actively trying to kill you.
Actively trying to kill you.
Yes.
Yeah, so it's completely random, and
my mom says, so I'm thinking that it could happen on another planet.
Yeah,
yes,
sure.
Statistically throughout the universe. Yes.
Yeah, and let's just look at let's just look at our galaxy alone. Milky Way galaxy has about 200 billion stars in it. We'll say that number kind of seems to fluctuate depending on surveys and
how
stuff.
important you want to feel.
Yeah. So 200 billion stars in it. Let's say 1% of those have the conditions where you might possibly have life on it. That's 2 billion stars.
Drake equation.
The Drake equation. Yeah, that's exactly what we're doing now.
The Drake equation, yeah.
And let's just say that 1% of those actually has a civilization on it. It doesn't need to be the civilization that at the point of their evolution where we're at. So it could be prior to us, or it could be more advanced than us. But let's just say that's 1%. Then you're talking 20 million stars in our solar system. In our galaxy have planets around it that have a civilization on it. 20 million fucking stars, and that's just in our galaxy. That could have. But that's just in our galaxy. We cannot be the only one.
Well, here's the problem, and this is something that I've talked about before, and an analogy that I use often, but it's like, here's the problem with this, is that, and I know we're getting a little bit off, but...
Doesn't matter, hangover.
That's true. Is that distances, our universe is so huge that, for example... And you guys are very well familiar with what I'm about to say. If there is a civilization on a planet 65 million light years away from us looking at the Earth and has the technology to see what's happening on our planet, that light from our planet is taking 65 million years to reach them, so they're seeing dinosaurs here. They're looking at our planet and they don't see humans or intelligent life.
They see dinosaurs dying.
They see dinosaurs dying. They can't see us yet, even though we're here.
Okay.
So the inverse also then applies.
And I want to build off what you just said and ask a question that is currently leaving my mind. What was the question? There it is. So there are ways to go faster than light. You cannot go faster. Let me bring that back. You cannot go faster, but there are ways to travel the universe and get there before light would have left your origin to destination.
Mike's making faces.
Einstein Rosencrantz-Pritz, the wormhole.
Okay, but that's
So
not
you-
a way. That's just a hypothesis.
Bear
That's
with
just
me.
an-
Bear
that's
with
a-
me. Yes,
Crim-
it is a hypothesis, but it's a hypothesis that multiple universes exist. So here we are.
Okay.
So if wormholes can exist, I'm assuming they would give off a strong energy
Signature.
Thank you, Star Trek. Yes, a strong energy signature.
Yeah, you have that
Right?
episode where it's the first stable wormhole. Okay, here's the thing: stable wormholes do not exist.
But why?
Nobel laureate Kip Thorne and
Oh, well,
Great
Kip
name.
Thorne over
Great
here,
name.
learning about black holes and being cool and stuff at UCLA. Well, let me tell you about Kip Thorne. He's a great person that should be listened to, and what I'm about to say should be disregarded because Kip Thorne says otherwise. So why can't wormholes exist?
because they figured out in the 1970s, golden age of black holes and wormholes,
Thanks, Stephen Hawking.
that you
Thorne.
need an exotic material.
Exotic.
I will get into that in a
Thank
moment.
you. 'cause that
Unobtainium.
sounds fun.
An exotic material to once you enter a black hole to keep it open. If
yeah.
you and when they say exotic, it is basically any material that we just don't know of in the
Yeah.
universe right now. And so let's say we make a spaceship and we go into this wormhole. Our spaceship not being made of exotic materials, the wormhole would instantly collapse.
Now,
And that's why they're not stable.
now, what
That
if
makes
some
checks out.
advanced civilization contacted us in some way and gave us instructions how to build this unobtainium material and spacecraft and to go through some kind of fast wormhole, and they could then meet us and talk to us?
I remember a scientist named Jodie Foster that.
That's who it was. It was what was her name? What was her name?
Yeah,
Of
what
course,
was
it's a
her name?
contact reference.
Okay, I might want to
J-
I might want to actually watch that tonight.
No, okay, yes, but also the book. Have you read the book?
Yes.
Holy
Yeah.
shit, is the book good?
Yeah, and it's different from the movie
Like-
slightly, but
Oh,
it's really good.
There's like 100 pages where the Jodie Foster character just goes to scientific
Ellie.
Ellie
That's
Conway.
it.
Ellie
That's
Conway?
it.
Yeah.
Yeah,
When
yeah.
she just goes through to a scientific conferences and pitches her case. Like there's 100 pages of that, and it's great.
Yeah. All right, so we're not going to be able to watch Lord of the Rings tonight. Let's watch
Contact!
All right.
Hell yeah, at the beginning. Let me tell you about the beginning, folks.
This will be the 5th show that we've said we will watch Contact after. We will be this time. We'll let you know.
Okay, exotic bacon.
Brandon, what if they see us as exotic bacon and they are trying to farm us?
One comment only,
That's why
Mr.
aliens want our cows,
Mr.
'cause
Jack.
the beef's so good.
If I am as tasty as bacon to another civilization, come and get me. I will gladly entice your tongue glands as you ingest me.
Okay. Any
God.
any civilizations,
Come
alien
and get me.
civilizations, when you show up, please take Brandon. Not me.
Because
Take Brandon.
for the moment before I am crunching your teeth, I will know more than anyone ever.
And then that knowledge will be immediately lost.
Yes,
You're
it's just like
digested
Hitchhiker's
whatever
Guide.
digestive glands they
Yes,
have.
it's just like the first chapter of Hitchhiker's Guide to the Galaxy.
Well, if you have a towel with you, you're fine.
Well, not at that point, because this woman in like Cambridge or whatever, England, figured out the secret to life, and she ran across the street to tell everybody that what the secret to life is, and then she was hit by a bus.
Oh,
Yes.
yeah.
Yeah, and for a scientist and it doesn't matter if they're physicists, astronomers, biologists, chemists, whatever. When they are working on their PhD, there is a moment in time, whether it is brief or whatever, where they are the only ones in the universe that know what they know.
So that moment, let me tell you, I love that moment so much. So I'm going to go off for a little bit here.
Okay.
So the first idea is that the universe has been around for 13.68 billion years, or 13.54. I don't remember.
Yeah, something like
Something
that.
like that.
13.8, 13.5.
Yeah.
And should we be the only intelligent civilization, there are many other life forms, but we haven't found proof of that yet, so we're going off what we know.
Yeah.
Should we be the only intelligent life form?
Caveat, intelligent meaning a way to utilize radio waves.
That works for me, because we're a bunch of dummies here.
Yeah.
Yeah.
And they discover something about the cosmos. Then they are the only thing in the cosmos that has known that before they disseminated across the world. It's fascinating. And then, what was the other thing I was going to say? What did he say? Remind me.
Oh, I was just saying that when they're working on their PhD,
Yes.
for that brief moment.
Yes, that brief moment. So my other favorite moment here is this was, of course, an Isaac Asimov quote. And it goes, the greatest discoveries never come with the eureka moments. It comes with looking at a data set and the scientist going, huh,
Yes.
that's weird.
Yes, pretty much.
Yeah, I love that. Now, there are some times like the Voyagers going across planets, sending pictures back and looking at it and discovering there's a plume on Io, a volcano, and being the only person because she looked at that picture of Io with a volcano and tried wiping it off because he thought there was dust on it, and it turns out it was a volcano.
To be fair, it's usually always dust.
It's usually dust.
Yeah,
as we discovered.
yeah. Or like getting the first picture from Hubble, the very first picture.
Oh,
Blurry
that's
picture?
the one I don't want.
And then realizing
Something's broken.
it's out of focus.
Get your drink. Get your drink.
Okay.
Get your drink.
Uh-oh.
To the not death of
Yes.
Hubble.
Oh,
The not death of Hubble!
Hubble lives!
So, for those of you asking what the hell is going on, for about a month, Hubble was offline because there was an issue and we couldn't solve it, and we thought after a couple. So it goes through issues every once in a while, and then after a week or two, it gets resolved. It is an old telescope.
It's in space too.
Yeah.
I mean, it's.
But this one went on for over a month. So after this month went by, we thought this might actually be
Hubble
it.
is our best window into the universe.
Yes.
But it came back. We solved it.
Yes.
And hell yeah, Hubble.
Yes.
Thank you, backup
Welcome
systems.
back. Oh, thank you. I mean, so much so that I've been teaching a class for Digistar, and for one of the classes, we actually have a conversation about it. It makes me upset. It truly made me upset that Hubble
And
potentially was. It has rewritten so
Absolutely.
many. It has rewritten everything we know about the universe.
Well,
Not even-
It's our best eyes.
not even rewritten. It has written itself. It has
Yes.
explored new worlds.
Oh, we don't have to take drink for
We
No,
don't,
it's Star
no.
Trek.
So we can have 20 James Webbs, each more advanced than the last, but there is only one Hubble. This was the first eye in the sky.
Yes.
This changed everything for us.
And to be fair, we are going to have to say goodbye to it
At some point.
at some point.
But it is not this day!
Oh, take a drink.
This day we look at the sky. Thanks, Hubble. Which reminds me, James Webb is likely going to launch this year.
This year.
Yeah,
this
2020.
year.
It was supposed to launch October 31st, Halloween, which thank God it didn't.
Halloween and
But it didn't because, or it hasn't been scheduled for Halloween, not because of James Webb won't be ready, but because of other external circumstances. So we're supposed to launch a crew to the space station Halloween, so that has precedence for NASA.
Are they allowed to dress up when they launch? No, they can't.
No,
And-
It would
no,
be
but
fun.
we will be eating
I'd paint my
peanuts.
face.
We will be eating peanuts that day.
Peanuts.
You don't know the peanut story?
No, what's the
okay,
peanut
continue,
story?
and then I'll do the peanut story.
I was just going to say that is our second Super Bowl of the year. Oh, our pizza might be here.
Pizza
Well, the
time.
pizza might be
I'm
here.
gonna tell the peanut
Okay.
story as Liz gets
The pizza?
the pizza,
Okay.
and the dogs go
I'm
off.
the one that doesn't know the peanut
I'll
story.
tell her the peanut story later. Or we can wait for a moment. Let's wait for a moment.
Let's wait for a moment.
All right.
Yeah, I mean, James Webb is just going to be... It's going to rewrite... All right, so Hubble rewrote books. James Webb is going to rewrite books as well.
Oh my God, the James. So for those of you who might be unfamiliar, first of all, go Google James Webb. So when we launched the Hubble launched on the back of a space shuttle Discovery, and they could fit pretty much nice and neatly within its cargo hold. I'm assuming you can hear dogs go off as well. So when
I had to drink for that.
Oh, that's right. That's so when Hubble went up and it was released from the space shuttle, and off you go. All I had to do was release the solar panels, and that was that. The James Webb has to do more than release solar panels. So it's going to be folded up like a complex origami and then fold. I think there are 200 mechanisms it needs to release, and these all have to work perfectly.
And keep in mind, this is not in low Earth orbit. Was it pizza?
Yeah.
This is not in low Earth orbit. This is 1 million miles away from Earth.
No.
We will never be able to take.
It's beyond the moon.
Yes, 4 times.
Oh,
the
James
distance
Webb, a
between
million
the
miles
Earth-
Yeah.
away from.
Yeah. So
There is no service mission
No.
to James Webb.
No, even if you have, the SpaceX Starship and everything work perfect, you still can't get there. This is it. So this is why it's been delayed for 2+ decades. It has to be fucking perfect.
Because in space, no one can hear you scream.
Well, I knew you were going to do that. I knew you were going to do it.
You have to look to your face, yeah.
Well, what I really love is Liz leans into the microphone, says her thing, and then leans back, looks at the camera, takes a drink.
Yeah. If I had sunglasses, it would be like CSI Miami. Alright?
Where he
And be
always
like,
takes
yeah!
the glasses.
Bum, bum, and then it goes into, who was it?
It was a Who song.
Who.
It's always the Who song.
Who are you?
Yeah. And that's like
That's
Masked Singer
yeah,
too.
that's as much as we can do for copyright reasons.
Okay, so peanuts. I am going to...
I forgot about this.
Peanuts, that's why I was
Oh,
waiting for
you
Liz.
didn't tell it, okay.
No, I waited for you, Liz.
Thank you.
Yeah. So I'm going to summarize as best I can.
Okay.
So in the late 60s, mid-late 60s, JPL had a string of failures going to the moon or the planets, what have you. Because it turns out, going beyond the Earth to other
It's hard.
celestial bodies is really fucking hard.
It's hard.
So they had a string of 6 or 7 failures in a row. And so JPL, when they had the Ranger missions, which was going to the moon at the time, as right before the Apollo missions got there, just to check out what's going on the surface, they had the Ranger 7. And during Ranger 7, somebody at JPL was like, hey guys, here's some fucking peanuts, and okay, this peanuts worked. And they had the peanuts, and Ranger 7 was successful. And so since then, every single mission JPL has attempted landing on, Curiosity, Perseverance, Spirit of Opportunity, everything, they've always had peanuts. Because see, peanuts everywhere.
Okay. Can I just say something? We all know my ears do not work.
Yes, it sounds like you're saying penis repeatedly.
Peanuts!
Penis.
Okay, I thought
Peanut,
that's what you were
which,
saying.
Yes,
to be
penis.
fair, JPL in the late
it
60s,
is dicks
penis
all around.
everywhere.
It's dicks all the way down.
JPL handing out penises everywhere.
Just like it's a bridal.
Yeah, bridal
bridesmaid,
shower with the
bridal,
lollipops.
Dicks all
bride-
around.
Bridal shower?
No, it's not a bridal shower.
Baby
It's-
shower?
it's
No,
the-
it's a
bachelorette shower.
Bachelorette party.
Thank
That's
you.
what it is.
Yes.
Little penis gummies being thrown out.
You get the penis, and you get the
You get the
penis.
penis.
Yeah.
It's our lucky penises.
So yes, peanuts. The object that grows out of the ground.
Lucky
If we
space
ever just like take off and we work at like a Comic-Con somewhere, we're just gonna hand penises out to everybody.
Yeah.
You get a penis. You get a penis.
You get a space penis.
We're all drunk.
Penises,
You get a penis.
Penis and peanuts. Just
Ladies-
Yes.
penises and peanuts. It'll be a grab bag.
Ladies and gentlemen, welcome to Cosmos with Cosmos, the Hangover Edition.
This is what happens.
All right, so let's take us all home here because our pizza just arrived.
Jack.
It
Oh.
does. It
Spaceship
does.
One does look like a bit like it does look like a dildo. I think I even said that, and I was like, why did they?
Yes. Yeah.
So one of the weird things
Of
about
course they did, of
the
course they.
big Falcon, big fucking rocket in SpaceX is it looks
Phallic?
Let me get there. It looks as though it's ripped out of 1960s science fiction, pulp science fiction, so that it costs like half a cent a word to create. But it's your stereotypical phallic object.
Yes.
Yes.
It has
So I like the idea that when people say, well, of course billionaires like it, it reminds them of what a giant penis should look like.
Ha ha!
Yeah! Sup, Musk, come at me.
Yeah. Compensating.
We have
Wow.
many things to discuss, Musk. Some are good, some are bad. Let's talk about it over a cup of tea. Sure. All right,
Anyway.
folks, our pizza just arrived. So, Mike, do you have any closing thoughts
Yeah.
to bring us home? And I'll go to
You're the
Liz.
birthday
So be
boy?
ready.
Oh shit!
We're gonna go through
I've been drinking quite a bit.
I'll close with me because I'm the host and I can close with me. So go with you
Well-
first.
Do what you want. Is that
Yeah.
what you're?
The universe is random, and even
Yes, Jack.
to me, the smallest constituents of the universe really have, great implications to the entire larger universe. And to understand the larger universe, you actually need to understand the very smallest members of it, the quarks, the leptons, and those.
3 cheers for Master Quark.
Yeah. All right.
Oh, sorry, that's a James Joyce quote as a English major here.
Okay.
And Finnegan's Wake.
Oh, it's my turn now?
I guess so, yeah.
I guess
sure,
so.
okay.
I
What was the
didn't
question
realize
again?
that we were going to have this question.
Closing thoughts.
Oh, closing thoughts. The universe is fascinating, yet also brain melting, and don't think about it too long, because it gets real tricky. Okay.
Or have drinks. It
Or
helps.
have some drinks. That helps. But the universe is amazing and terrifying. Not a friendly place.
No, it's trying to kill you.
Trying to kill you, but somehow life has found a way.
Oh.
Because life always finds a way.
Can you say it? Can you say the full quote?
That's what I just said.
But you did the pause and things.
I just said life always
No,
finds a way.
you're right. I just wanted the full
I
Goldblum.
I don't know if I can do the full Goldblum. It's your birthday!
Holy shit, that was beautiful.
Take it away, Brandon.
All right, so there is a quote that I'm going to butcher, but let me get there in a moment. So we
Okay.
were talking about the
Cross
building.
my legs 'cause
Yes, of course.
fancy.
This will be a moment if I get the words right. So the building blocks in the universe goes from point particles to molecules to foundational objects of moons, planets and stars, the galaxies, universes, and the cosmos.
Yes.
But as we have discussed, the larger that you look at, the smaller you must study to understand it. So, get your drinks ready. I don't recall the exact quote here, but you'll know it. The smallest among us will have the greatest impact in this world.
Definitely.
Looking at you, Frodo Baggins.
Sam's the real hero.
Well, that's another conversation. So with that, ladies and gentlemen, thank you for joining us for The Hangover. This was a fantastic, wonderful episode. I look forward to doing it again when we talk about space tornadoes.
Space tornadoes!
Space tornadoes!
Space tornadoes.
So with that, y'all have a great evening, afternoon, morning, whenever you decided to listen/watch us. And
we'll see you in 2 weeks.
see you next time, folks.
Cheers, everybody.
Bye!
Pizza time.
Pizza
Pizza
time.
Mathematical.
I always don't know
Algebraic.
how to end the algebraic. I always don't know how to end the thing because I have to do it like manually.
Space.
And
The
then I
final
go by
frontier.
They're
These are the
all
voyages of
watching
the
this.
cosmos with Cosmos. It's 3-year mission to explore
5-year
new
mission.
topics. It's 5-year mission to explore new topics, to eat new pizza,
I just
and
got-
to